Okay, here we go. This is our notes page for lesson 8.2.2, ratios of similarity. Question 8-78. Team photo. Alice has a 4-inch by 5-inch photo of the girls' ice hockey champs, which she needs to enlarge. Part A. Which size should she pick? 7 by 9, 8 by 10, or 12 by 6? Well, we need to pick a shape here that's similar so that when she enlarges the photo, it's got the same proportions as the previous one. Let's take a look at these dimensions here. The only one that matches up to me when I take a look here is, we get 4 by 5. And if I scale each of those dimensions up by 2, I get the 8 by 10. The other two don't match with the same scale factor on each set of sides. So we're going to go with the 8 by 10. And there's a scale factor of 2 on that enlargement. Okay, now let's move to part B here. The cost of her photo paper to print Alice's 4 by 5 picture was a whopping 45 cents. How much should it cost to print the enlarged photo? Well, let's assume that the cost is proportional to the area of the picture. We had a scale factor of 2. That means that our area ratio will be 2 squared, which is also known as 4. So that means our new cost should be 4 times what the old cost was. And if you take 45 cents, multiply by 4, you get $1.80. All right, let's move on. Part C, the assistant principal also went out and ordered an enlargement of Alice's photo. However, the photo paper for his enlargement cost $7.20. Big spender. What are the dimensions of his photo? Well, let's do it this way. So let's find the area ratio by looking at the cost ratio, because we made this comment up here. The cost should be proportional to the area. So if we look at the area ratio, should be equal to the ratio of those two costs, $7.20 divided by 0.45. And that gives us 16, a value of 16. So if the area ratio is 16, we have to find some number for the scale factor that when we square it, we get 16. Well, we can do that by unsquaring 16, also known as taking the square root, and that gives us 4. So the new dimensions of the assistant principal's picture are 4 times the size of the original. The original, if you remember, was 4 inches by 5 inches. So if we quadruple each of those, we get 16 by 20. Thank you, assistant principal. Okay, let's move on to question 8-79. 8-79 is a long one. What we're asked to do in this problem is analyze pairs of similar shapes, and we're going to do that by completing all the information in this table. So you'll notice the table includes side ratio, perimeter ratio, area, and area ratio. So I need to calculate all of those things for 3 different sets of shapes. And I'm going to go ahead and scroll down to the first shape. I'll do this one. We'll go through this one kind of slow, and then I'll do the other ones much quicker. So let's first take a look at what's going on with these 2 rectangles. So how do we get from 25 to 15? Well, if we look at the scale factor is going to be 15 over 25. And we can divide both of those by 5. That gives us 3/5 as our scale factor. So that means we need to find this value here. I'll call this x. If the scale factor is 3/5, that means 6 divided by x should equal 3/5. That gives me 3x equals 30, or x equals 10. So now I know the other side length here, and I'm going to call this shape 1, shape 2. We're going to do some perimeter work here. And that perimeter is 42 for the smaller shape. Let's look at the perimeter of the larger shape. And that's 70. These are in just plain old units. We don't know if they're inches or miles or what. Now let's look at area. The first shape has an area of 6 times 15. 90 square units. Second area has a shape of 10 times 25, and that's 250 square units. Okay, I think we've calculated everything we need to. Let's go up and fill out the information in the table. So the side length ratio, we're going to look at small divided by large. We already have that value. The scale factor is 3/5. The perimeter of the smaller shape was 42. Perimeter of the larger shape was 70. And the perimeter ratio is going to be 42 over 70. And that reduces to 3/5. Area ratio, or area here, we had 90 square units for the small shape, 250 for the larger shape. That gives us an area ratio of 90 over 250, and that reduces to 9/25. Okay, we're going to do the same work for the second and third set of shapes. I'm going to go through it much quicker, though. For these triangles, I should notice right away that they're 30, 60, 90 right triangles. And I know that in a 30, 60, 90 right triangle, the hypotenuse is 2 times the short leg. And then the long leg is the short leg times √3. Uh-oh, these are going to be some crazy numbers in this problem. Now, for this smaller one, I have the hypotenuse, so I cut it in half to get the short leg. And then I multiply by √3 to get the long leg. Let's call this shape 1, shape 2. And let's go ahead and do our area and perimeter calculations. I'm going to go ahead and give an approximate value here. That's about 9.464. That's using the calculator to approximate the square root of 3. And this one we get 28.392. Area of the first shape is 1/2 base times height. I'm going to do an exact value here. 1/2 times 2 is 1, and 1 times 2√3 is 2√3. Second shape has an area of 1/2 times 6 times 6√3. 1/2 of 6 is 3. 3 times 6 is 18, so that's 18√3. And again, these are units, and these are square units. Okay, let's go ahead and fill out our table with that information. So our ratio here, we forgot to talk about scale factor. Let me scroll back down and take a look at that. Well, I've got, let's compare this side here to this side here. Scale factor is 4 over 12, and I know that simplifies to 1/3. So the side length ratio is 1:3. Perimeter here was about 9.464 for the small shape and about 28.392 for the larger shape. If I divide 9.464 by 28.392, I'm going to get 0.3333 on my calculator, and that is 1/3. Let's take a look at the area ratios. Remember, we did these as exact values: 2 times the square root of 3, 18 times the square root of 3. And if we divide 2√3 by 18√3, we get 1/9. Okay, so I'm starting to see a pattern here. Okay, I'm starting to notice that these two numbers are the same, and this number is the square of the perimeter ratio, or the square of the side ratio. Okay, let's continue on. For the next one, the third shape, you're going to have to flip to the back side of your notes. There we go. There's our third set of shapes. And these ones look like trapezoids to me. And don't forget this. The area of the trapezoid is equal to 1/2 times the sum of the bases times height. We got our work cut out for us on this one because we're going to have to actually calculate the height. I don't think it's going to be too much of a challenge. First of all, I noticed this. To go from 5 to 40, I'm multiplying by 8. And we were told that all these shapes are similar, so I'm going to just multiply by 8 to get all of these dimensions. 13 times 8, that's 104. I noticed that these are all the same length here, so that means these are all going to be the same length here. Now let's talk about the height. Height's a little trickier. If I drop a perpendicular right here, that means this length here will be 5. That means I have 8 more units to get to this 13. And by symmetry, we're going to have 4 over here and 4 over here. So now what I'm working with is a triangle that has a leg of 4, a hypotenuse. It's a right triangle. It's got a leg of 4 and a hypotenuse of 5. That means the other leg has to be 3. Okay, that's our friend, the 3, 4, 5 right triangle. Okay, and if this scale factor is 8, that means I have to multiply these dimensions by 8 to get this larger size. So 4 times 8, this is going to be 32. 3 times 8, 24. Really, this is the only one I needed because that's my height, which I need for my area calculation. Okay, so we've already talked about scale factor here. If I compare the small one to the large one, it's 1 over 8. Now let's look at our perimeters and our areas. Forgot to tell you folks, this is the same standard procedure I was using in the other problems. Smaller shape was 1, larger shape was 2. All right, now it's time to check back in with our table and kind of fill out some of the information we just calculated. So let's scroll back over to our table. Okay, so scale factor here, side length ratio was 1 to 8. Perimeter we had was 28 for the smaller shape and 224 for the larger shape. If you do 28 divided by 224, you're going to get a decimal of 0.125. Some of you might be like, oh my God, I don't know what that is as a decimal. It's 1/8. Okay, and I'm going to give you a little trick here. If you ever get a decimal and you're not decimal on your calculator and you're not sure what that is as a fraction, try flipping it around. If you do 224 divided by 28, you're going to get 8. That means if we do the reciprocal, you're going to get 1/8. Okay, that's a little trick for you on your calculator. Okay, now what did we get here for area? We got 27 units here, and we got 1,728 units here. And that's a ratio of, hey, try that little trick I just talked to you about, because if you do 27 divided by 1,728, you're going to get some crazy fraction. But if you do 1,728 divided by 27, you're going to get 64. Okay. So, all right, folks, we're done with this problem. And again, what does this illustrate to us? The side length ratio and the perimeter ratio are equal. The area ratio is the square of the side ratio, or the square of the scale factor. Okay, this is just reinforcing things that we've already talked about in previous lessons. All right, let's move on and look at question 8-80. Is there enough information to determine if the shapes are similar? Justify your conclusion. Well, let's take a look here. We go from 7 to 21. So we ought to be able to talk about the scale factor. And I'll do large on top and small on bottom. 21 divided by 7, that's 3. Okay, so we got a scale factor of 3. Now let's check the area ratio. Well, if I take the second area and divide by the first, I get 360 square feet. Divided by 40 square feet, and that's equal to 9. And I don't know about you, but that looks like it matches our model of taking the area, the side length ratio or the scale factor, and squaring it to get the area ratio. So I'm tempted here to say yes, they're similar. I'm totally tempted to say yes, but the truth is there's really not enough information. It fits our model. Fits that model of area ratio equals scale factor squared. We really would need more info here. The shapes look similar. So yeah, this one's a little tricky. It fits our model of that area ratio is equal to scale factor squared, but we would need more info. The shapes look similar, but even though the shapes grow proportionally, that does not guarantee that the shapes remain the same. We would need more information. Okay, Let's move on to the last question here, 8-81. Your teacher enlarged the figure so that the area of the similar shape is 900 square centimeters. So this is going to be, we'll call this area 2. What is the perimeter of the enlarged figure? So we need to know the perimeter of the enlarged figure. That we'll call that P2, and that's what we're looking for. So if we're looking for P2, let's go ahead and calculate P1 real quick. We'll call this shape 1. This perimeter is going to be 13 plus 10 plus 5 plus 4 plus 8 plus 4, and that's 44 units. We have some information about area here, so we can look at the area ratio. We're told the enlarged figure has 900 square centimeters of area. The original had 100 square centimeters of area. That gives us an area ratio of 9. What about the scale factor? Well, we have to figure out what number squared gives us 9. We can do that by unsquaring 9 or taking its square root, and that gives us 3. So the scale factor we know from our work on the previous page. If I take a look back over here at the first page, we know that the scale factor is equal to the perimeter ratio. So if I can use that fact to help me find the perimeter of the new shape. P2 over P1, that's supposed to be a 1. P2 over P1 has to equal 3. So that means P2 over 44 has to equal 3. And that gives me the perimeter of our larger shape is 3 times 44, which is 132 square centimeters. Oops, whoa, not square centimeters, 132 centimeters, because perimeter is a length. Notice here I put units. That's a mistake, folks. Units here of length are in centimeters. All right, that's it for 8.2.2. That was pretty straightforward. Good luck with the review preview.